Hi, I'm Fabio Sassahara, and welcome to this What's New in the Highway Capacity Manual 7th edition series. For this video, we'll be talking about the new enhancement to the pedestrian level service methods that covers a few chapters of the manual. So let's get started with uncontrolled intersections or two-way stop control. That's the major change in the methods. And let's compare what we have in the 6th edition and what we have new in the 7th edition. So in the previous edition, level of service for pedestrians was based on pedestrian delay, and it was sensitive to hourly traffic flow rate in the major street, plus motorist yield rate, which is the rate at drivers comply to pedestrians. We know that every driver should comply to pedestrians, but that's not what happens in the real world. So that's one parameter that we model that degree of driver compliance. What we have in the 7th edition is now, level of service is defined by the proportion of dissatisfied pedestrians. And now we have a few more parameters that we can plug into the equations. For example, we still keep the hourly flow rate, but we can also consider the AADT, or annual average daily traffic, in our major street. We still consider motorist yield rate, and we can also consider effects of different safety treatments that we'll be talking about in a moment. For example, crosswalks or flashing beacons or halt signals, for example. We still use control delay in the equation, but it's just part of the level of service framework. There are other elements, especially related to safety and comfort, that are implemented in the new methodology. And also, there are several corrections to some equations that have also been implemented in the 7th edition compared to the 6th edition. For the next slide, we can compare both service measures that we had in previous editions. So as we mentioned, for 6th edition, everything was based on control delay, how many seconds are added to every pedestrian, and we have the ranges here. So any delay greater than 45 seconds would translate into level service F. In the 7th edition, the table at the bottom, we have this percent of dissatisfied pedestrians. So we get a level of service A when less than 5% of the pedestrians are dissatisfied, but we get a level of service F when more than 50% of the pedestrians consider this crossing experience as a dissatisfying one. And this is how it's implemented in the highway capacity software. So when we're modeling pedestrians, we can model, for example, what is the specific crossing treatment that's being applied here. So if we're modeling, for example, a rectangular rapid flashing beacon or RRFB, so each one of these treatments, they have a related motorist yield rate, which can be implemented automatically here, and they have different effects on the performance of pedestrians. Higher the yield rate, higher is going to be, or better is going to be the performance measure for our pedestrians. How we get this yield rate? So this is based on this table. This is part of the HCM 7th edition chapter for two-way stop control. And these numbers, they are based on a series of literature findings. They are all summarized here. But as you can see in the top, when you don't have any sort of treatment, no crosswalks, you can expect, for example, yield rate of 24%, or only 24% of the drivers, they actually yield for pedestrians. But when you add a crosswalk and you start adding additional safety treatments and you can go down through the table, you can see that driver compliance increases. So for example, we can get for a flashing beacon around 82% compliance, or we can get even 91% for halt signals, and so on. What we also have new in single line intersections, there are different changes in the methodology. So again, we can compare the 6th edition and the 7th edition. In the 6th edition, for example, we could only calculate delay for a single leg or a single stage crossing. And level of service was based on pedestrian level of service score. We still have the same service measure, so this did not change on the 7th edition. But new features that have been added now is we can account for the performance of multiple legs being crossed. For example, we can cross from this corner and we can perform a two-leg crossing. Main difference is that when we are doing a two-leg crossing, the second crossing is not random. So for example, when you do a single leg crossing, everything is random because the pedestrian can arrive here at any moment of time within the cycle. So you may have to wait one entire cycle to cross, or you may arrive right before the walk phase. But when you look at the two-stage crossing, the second crossing is not random because when you finish the first crossing, you know exactly where you are within the cycle. So that leads to a more accurate estimate of pedestrian delay in those cases. Also, the new 7th edition also implements the barn, dance, or pedestrian scramble, so you can analyze this operation when you interrupt all vehicular traffic and you assign a walk phase for every pedestrian in the intersection. And when we're talking about urban street segments, which is also affected by the changes in the 7th edition, the methodology is now more sensitive to diversion length, and that means when you're in the middle of the segment and you as a pedestrian have to walk a certain distance to your boundary intersection either way to get to cross. So the methodology now gives more weight to that diversion length, and that has been reflected in the equation that we have in the new methodology. Let's now discuss a quick example to illustrate this change in the two-way stop control pedestrian level of service. And what we have here, we're analyzing a two-way stop control, and we are focusing on the pedestrians crossing the eastbound approach, as you can see here in the figure. So for this base condition, we have a very narrow median that does not allow any two-stage crossings. We have no crosswalks, and we have all the vehicular and pedestrian demands here, with an average pedestrian walking speed of 3.5 feet per second, which is the recommended average. And when we plug in the numbers and we analyze this pedestrian crossing for these base conditions, we get some performance measures that are not really very favorable. So pretty high numbers of delay, so almost 500 seconds of delay per pedestrian for the eastbound approach, and 82% dissatisfied pedestrians, which results in a level of service F. But then let's see what would happen if you want to analyze different safety treatments for different cases, how much that would affect the level of service for pedestrians. So here we have three different options for solutions. Option A, we're going to implement pedestrian crosswalks, as you can see here. In option B, we're going to keep the crosswalks, and on top of that, we're going to implement a wider median refuge. So that would allow pedestrians to cross in a two-stage crossing, so they can stop at the median and then proceed. And option C, on top of everything we have before, we are also going to implement a rectangular rapid flashing beacon, as you can see here. And let's see how that affects calculations for all these cases. So option A, what we do when we analyze this in the software, we're going to check the presence of crosswalks, and this will change the yield rate from 24% to 0.33 or 33%. So that reduces my delay to 64 seconds, and the percent of dissatisfied pedestrians now goes to 61%. It's still a level of service F, but it's an improvement compared to base conditions. Then option B, what we do here, we implemented a wider median refuge. So what we changed here is that now we have two crossings instead of one, each one of them with 20 feet, as opposed to a single crossing of 52 feet with the same yield rate, 33%. And when we run the methods, now we have about 15 seconds of delay per pedestrian, 18% dissatisfied pedestrians, and that results in a level of service C. So that's a significant improvement. And for case C, what would happen here is, on top of everything else, we implemented a rectangular rapid flashing beacon. We select the treatment, as you can see here in the screen, and that results in a new yield rate of 82%. So more compliant drivers, that will now result in an average pedestrian delay of 4 seconds per pedestrian, and 2.1% dissatisfied pedestrians. So now we can achieve level of service A. So that's the strength of the methodology. With a few safety treatments, we can go from level of service F to A. We can be more sensitive to safety and comfort of pedestrians. And that's how we can analyze pedestrian level of service for this new methodology of HCM 7th edition. With that, thank you very much for watching.